Hello students. So in the previous video we took some examples based on the properties of DTFT. That means how we can use the properties of DTFT to solve the problem or to get the end result. Okay. Now I'm taking a different kind of problem in this video, and also I'll take some example on inverse DTFT as well. Some unique kind of problems here. Now here we have a spectrum given. Those are magnitude and phase spectrum. For this we have to determine a time domain signal. Now time domain signal means you have to find x of n. That is the meaning of it. Now this is the spectrum here. So first one is the magnitude spectrum of the signal x of e power j omega. I can see the signal is varying from 0 to pi, pi to 2 pi and 3 pi, and the value of this is sine omega. Now here in the negative side you can see this, the same signal has been repeated. So that means if in this negative sign or negative side the value of this is minus sine omega. So even though if it is not given, you have to understood that this value is minus sine omega. So you can check that by applying the value for omega. So you'll get this one, minus sine omega. Now coming to this problem, we have the phase given for the same magnitude and phase spectrum of this. So this is given. Now based on this we have to find out what is the value of x of n. Okay. Now let's start with the solution. Okay. So now if you observe this from the figure, so from figure we have to define x of e power j omega. So we have two different values for x of e power j omega from minus pi to 0 and 0 to pi, that we have to define. So from minus pi to 0 we have minus sine omega e to the power of j to omega. Now why you have been wondering why we have e power j to omega? So that is mainly because of the phase of the signal. If you observe this, here we have the phase at pi you have minus 2 pi, and at minus pi, and at pi we have 2 pi, and at 0 we have the amplitude 0. That means if omega is equal to, if you substitute this omega is equal to pi, then you will get 2 pi here, and if omega is equal to minus pi, then you will get minus 2 pi for the signal. So that is the phase of the signal. So we have to consider both of them. So we have solved a similar kind of this in the previous video. You can take you can refer that, where we got e to the power of minus 2 omega. That means you will get some 2 omega as your phase of the angle, but for that your signal should be e to the power of j 2 omega. That is your x of e power j omega value. You can refer that, a similar kind of one, but I think it's a reversed one. You can refer that one. So based on that we have written. Now what is the duration of the signal? This signal is from minus pi to 0, omega varying from minus pi to 0. Now x of e power j omega is sine omega e power j 2 omega for the duration 0 to pi. Okay. So this is what we have, x of e power j omega. Now we have to find x of n. So we use this expression, x of n is equal to 1 by 2 pi integral of minus pi to plus pi x of e power j omega into e power j omega n d omega. Now since we have two different duration for this signal, so that's why let's represent x of e power j omega in this particular duration, from minus pi to 0, we have minus sine omega e power j 2 omega and e power j omega n d omega plus, so I have less space there, I am writing this here, plus integral of 0 to pi sine omega e power j 2 omega into e power j omega n d omega. Now this is what our x of e power j omega. If you go further, so express this taking minus outside here. So this sine omega, if you convert that into exponential, so you will get e power j omega minus e power minus j omega divided by 2j into e power j 2 omega e power j omega n d omega. So this is the first part, plus integral of 0 to pi e power j omega minus e power minus j omega divided by 2j into e power j2 omega e power j omega n e omega. Now this 2j, we can take it outside and we can combine these values. So let us see what happens here. 1 by 2 pi into, so I am taking this 2j outside, so 1 by 2j integral of minus pi to 0. This one, if you combine this, that means I am going to multiply with this one, so you will get e power j 3 omega e power j omega n minus e power j omega e power j omega n d omega plus 1 by 2j integral of 0 to pi. So same thing you are going to get here also, only thing is the limit will be different here. Now all have common base, now you can combine them. So 1 by 2 pi into minus 1 by 2j integral of minus pi to 0 e power j, so you can write it combining this e power 3 plus n to omega. So this one, that's the first part, minus e power j 1 plus n into omega d omega. So this is the first part, plus 1 by 2j integral of 0 to pi e power j 3 plus n omega minus e power j 1 plus n omega d omega. Now if you integrate this, you get 1 by 2 pi minus 1 by 2j. So I am writing the integration of that, e power j 3 plus n omega divided by j 3 plus n minus e power j 1 plus n omega divided by j 1 plus n, and the limit is minus pi to 0. So this is the first part, plus 1 by 2j into e power j 3 plus n omega divided by j 3 plus n minus e power j 1 plus n omega, the limit is from 0 to pi. Okay, so now apply the limits and try to simplify. I'm not going to elaborate this further. If you do so, you should get the answer like this: 1 minus 1 to the power of n plus 1 into minus 1 divided by pi into n plus 1 into n plus 3. So it takes much longer to simplify. So that's why you just apply the limit and simplify. You should get this answer. So I have to take. I'll take some other problems in the meanwhile. So that is the reason I'm not going to elaborate on this one. So just simplify, apply the limit and simplify. You should get this. So eventually we'll get there, but the process might take some time for you to solve. So this is the final answer you are supposed to get. Okay, so the most important thing is the defining the signal here from this diagram, phase and uh, magnitude spectrum. We have given sine omega. This is not given, so this is nothing but minus sine omega. So that we defined. So this, most of the time if you forget this, then the problem will be wrong. You have to consider this with respect to the phase. So that's why both are given here. So if you take only sine omega and go on substituting and simplifying that, that would be wrong. Okay, so writing the equation, so this signal, mentioning the signal is the important part of the problem. After that, the remaining is just substituting and trying to simplify as much as possible. Okay, so this is one kind of problem here. Now I'll take a different one. So it looks simple, but you have to deal with the final one. And so this kind of problem I have not taken. So let's go for it. So the problem is given like this: find the DTFT of the signal. So given x of n is equal to cos pi by phi n plus j sine pi by phi n, where mod n is less than or equal to 10 and it is 0 otherwise. So observe here, mod n is given, so that means n can take positive or negative value. Whatever the condition it takes, the value should be less than or equal to 10. So if it is taking negative value, then it will be less than or equal to minus 10. If it takes positive value, then it will be less than or equal to plus 10. So we have to consider both the positive and negative values here. That will be easier for us. So the 0 part we are not considering. So let's take the part where the signal is present. So x of n is equal to cos pi by phi n plus j sine pi by phi n here. Now if you see this, you can express this in exponential form as e power j pi by phi n. So this one is the simplest form of representing that. Now it will be easier for us to find out. Now we have to find the DTFT of the signal. So given signal is x of n, so therefore x of e power j omega is equal to summation n varying from minus infinity to plus infinity e power minus j omega n. Now this one, I forgot to mention this. So the value is n can take positive or negative value. So the limit will be from, if it takes negative value, then n will be varying from minus 10. If we take positive value, plus 10. So both we have to consider. So our limit will be n is equal to minus 10 to plus 10, and x of n is e power j pi by phi n into e power minus j omega n. Now if you combine this, n is equal to minus 10 to plus 10 e power j pi by phi minus omega into n here. Okay. So now this limit is from minus 10 to plus 10. So for my convenience, I am just changing the limit here. So it should be one duration like minus pi to plus pi. We can take the limit from minus pi to plus pi as 0 to 2 pi. So both suits better. Now I am going to make the change something like that. So to make that happen, I will replace this n with some other variable. So I'll put n is equal to m minus 10. So that makes the lower limit as 0, and upper limit will be 10 plus 10, that is be 20. So this allows me to write m is equal to n plus 10. So if there is a need for this, we have to write that. Okay, so let's make this change here. Summation m is equal to 0 to 20. You can check that. I'm just m minus 10 is equal to 10 here. M is equal to 10 plus 10. So m will be equal to 20. So this is the upper limit. How you got 20? Okay. Now here e power j pi by phi minus omega into, in place of n, we have to replace that with m minus 10. Now if you multiply that, you will get m is equal to 0 to 20 e power j pi by phi minus omega into m, and e power minus j pi by phi minus omega into 10. Okay. So now this one we can take it outside from the limit. So it will give us minus j pi by phi minus omega into 10 summation m is equal to 0 to 20 e power j pi by phi minus omega into m. So now from the geometric series, we have something like, if n is varying from 0 to n, a to the power of n, so that can be written as 1 minus a to the power of n plus 1 divided by 1 minus a, if a is less than 1. Now based on this, we can write our expression as, so I am applying this to this one. So 0 to n is there, so we have 0 to 20. So n plus 1 means 20 plus 1 I have to write. Now in place of a, we have e to the power of j pi by phi minus omega. So this complete thing is a here, and n plus 1 is, so this value we have to substitute. Okay. Now based on this, you can write it like this. I want some more space, so that's why I'm going to write from here e power minus j pi by phi minus omega into 10. So now I am applying this. So that gives us 1 minus, in place of a we have e power j pi by phi minus omega, and 20 plus 1 gives us 21. Okay. Divided by 1 minus e power j pi by phi minus omega. Okay. Now if you simplify this, so e power j minus j pi by 5 minus omega into 10. So this multiplied by, so I am rewriting this part. So you get e power j pi by 5 minus omega 21 by 2, yes, into e power minus j. So this whole thing divided by e power j pi by 5 minus omega. So power is 1. So I will take 1 by 2 into e power minus j pi by 5 minus omega 1 by 2 minus e power j pi by 5 minus omega into 1 by 2. Okay. So if you continue this further simplification, I think you should get here you get cancelled. You get e power minus j pi by 5 minus omega 21 by 2 minus e power j pi by 5 minus omega 21 by 2 whole divided by 2. So divided by e power minus j pi by 5 minus omega into 1 by 2 minus e power j pi by 5 minus omega into 1 by 2 whole divided by 2 here. So based on this, you can see e power j theta minus e power j theta by 2. This can be written like this: sine pi by 5 minus omega 21 by 2 divided by sine pi by 5 minus omega into 1 by 2. So this is our x of e power j omega. So given is x of yes, x of e power j omega. So this is the solution for this problem. Okay. So now I will take one more, a different one. Yes. So given, so it is like using partial fraction expansion, comma, determine the inverse DTFT of the signal. So x of e power j omega is equal to 3 minus 1 by 4 e power j omega divided by minus 1 by 16 e power minus j 2 omega plus 1. So this is the problem. So we have to find x of n by using partial fraction expansion here. So that is the inverse DTFT we have to perform using partial fraction. Now while applying this, so we have to make slight adjustment here. So in the denominator it is minus 1 by 16 e power minus j2 omega plus 1 is there. So I am just rewrite this. So I am rewriting this 3 minus 1 by 4 e power minus j omega divided by 1 minus 1 by 16 e power minus j 2 omega. Now if you observe this denominator, we can express this in the form of a square minus b square. This can be taken as a, and this term is entire term is b. So that will be a plus b into a minus b. So based on that, you can write the denominator in this form 3 minus 1 by 4 e power minus j omega divided by, so a square means 1 square, so 1 a plus b, first one a plus b, 1 plus 1 by 4 e power minus j omega, because we have j2 omega here, so the square has been taken, and a minus b is 1 by 1 by 4 1 minus 1 by 4 e power minus j omega. So this, so you have to apply partial fraction expansion, means so you have to express the denominator in this form, it will be easier. Now so using partial fraction expansion, so before going to that, see, if you have something like x of e power j omega given as a divided by 1 minus alpha e to the power of minus j omega plus b divided by 1 minus alpha e to the power of minus j omega, like this. So we have to find the value of a and b. So a is found out in this way, 1 minus alpha, that is whatever the denominator of a. If you want to find b, then take the denominator of b here, e power minus j omega into x of e power j omega. That means you have to substitute x of e power j omega, where e power j omega is equal to alpha. Now after substituting x of e power j omega, then e power j omega should be replaced by the value of alpha. That's why, that is this value. So this you have to, it should be 1 minus alpha e power minus j omega. It should be in this form only. Okay, so if you have some 1 plus means, then it becomes minus alpha. If you have 1 minus alpha e power minus j omega, then it will be plus alpha, like that. Okay, or here itself I will just change that. If you want to find b, then 1 plus alpha e power minus j omega x of e power j omega, where e power j omega takes the value minus alpha. So this is these are the two cases you have to remember while finding the values here. Why? Because plus is there, alpha becomes minus. If you have minus, you have to just substitute plus alpha there. So this is how we are going to find the partial fraction expansion here. Now first I will express this, x of e power j omega is equal to a divided by 1 plus 1 by 4 e to the power of minus j omega plus b. You can use any alphabets. You can use, here I'm using a and b. You can use like a1 a2 or b1 b2 k1 k2 c1 c2, anywhere, anything, it's up to you. You can use different alphabets or variables if you want to. So 1 minus 1 by 4 e power minus j omega. So now we have to find the values of a and b. So a is equal to, so before going to that, give a name for this one. So this is our x of e power j omega, which we have to substitute there. So a is equal to, so the denominator is 1 plus 1 by 4 e power minus j omega. So this is 1, this I have written. Now next, our x of e power j omega, that I have to write, that is 3 minus 1 by 4 e to the power of minus j omega divided by 1 plus 1 by 4 e to the power of minus j omega and 1 minus 1 by 4 e to the power of minus j omega, and here e power j omega will take the value of alpha. Now here if you compare this, we have 1 minus alpha e power minus j omega. So in place of alpha we have minus 1 by 4. So that will be minus 1 by 4 here. Okay. So next, these two get cancelled here, and we remain with 3 minus 1 by 4 e to the power of minus j omega divided by 1 minus 1 by 4 e to the power of minus j omega, where e power j omega will take the value minus 1 by 4. Let's substitute that. Here you observe we have e to the power of minus j omega. So that means e power minus j omega can be written as, if you go to, it will be equal to minus 4. That means this can be written as 1 by e to the power of j omega. So then our value will be 1 divided by 1 by 4, that is equal to minus 4. So 3 minus 1 by 4 into minus 4 divided by 1 minus 1 by 4 into minus 4. So 4 get cancelled here, 4 get cancelled here, minus 1 to minus become plus. So this will be 3 plus 1 and denominator is 1 plus 1. So that will give you the value as 4 by 2, that is equal to 2. So that means value of a is 2 here. The same way b is equal to 1 minus 1 by 4 e to the power of minus j omega. So I am writing the value here, this one. Now x of e power j omega, same thing, 3 minus 1 by 4 e to the power of minus j omega divided by 1 plus 1 by 4 e to the power of minus j omega into 1 minus 1 by 4 e to the power of j omega, and e power j omega will take the value of alpha. So alpha value is plus 1 by 4 here. Now this to get cancelled, and we remain with 3 minus 1 by 4 e to the power of minus j omega divided by 1 plus 1 by 4 e to the power of minus j omega, where e to the power of j omega will take 1 by 4. So here e power minus j omega will be equal to plus 4. Okay. So 3 minus 1 by 4 into 4 divided by 1 plus 1 by 4 into 4. 4 get cancelled here, and here we will remain with 3 minus 1 divided by 1 plus 1. So 2 by 2, it is equal to 1. So value of b is equal to 1. Now if you substitute that, value of a and b. So x of e power j omega is equal to 2 divided by 1 plus 1 by 4 e to the power of minus j omega plus 1 divided by 1 minus 1 by 4 e to the power of minus j omega. So if you go to the next part, so I just want to remember some of the basics here. if alpha n u of n, if you perform DTFT for this, so you will get x of e power j omega as 1 minus alpha e to the power of minus j omega. So this one we solved in the very beginning. That means after this part we have to take inverse DTFT for x of e power j omega to get 1. So that means we have this part, so we have to get this one. Now if you observe this, both the denominator are very similar to this, so except the numerator, you have 1 here, we have 2 here, so that is not an issue. So the denominator, if you see, they are look similar to this. That means our x of n will be something like in the form of alpha n into u of n, where alpha value might be difference from one signal to another one. So based on this, taking inverse DTFT of x of e power j omega, so this has to be done on both sides. So if you reverse the process, x of e power j omega will give us x of n is equal to, now so compare this, we have 1 minus alpha e power minus j omega, so we have plus alpha here, so that's why you get 1 minus alpha. So here we have 1 plus, that means alpha value is minus alpha. So 2 into minus, in place of alpha what do we have, 1 by 4 to the power of n into u of n. So this is the first part. 2, that is the amplitude, 2 is the amplitude that I have written here, and in place of alpha we have 1 minus here, we have 1 plus, so that means alpha value will be minus 1 by 4 to the power of n into u of n, plus here 1 is the amplitude, 1 is the value here, so that I am keeping as it is. So that means 1 minus alpha e power minus j omega, we have 1 minus 1 by 4, in place of alpha we have 1 by 4, so I am writing 1 by 4 to the power of n into u of n. So this is the value of x of n after substitute taking the inverse Z transform. So to apply inverse Z transform, you have to remember some of the standard DTFTs like delta n, u of n, alpha n into u of n, etc. and the time shifted version of them. So you have to remember this. So it will be helpful in applying while applying the inverse Z transform, inverse DTFT for the signal. Now you can try a similar kind of problem here. Try this at home on your own. Given same using partial fraction expansion, you have to find x of n. So x of e power j omega is equal to 6 divided by e power minus j to omega minus 5 e power minus j omega plus 6. So this one you have to find the roots, the denominator, and you have to express the x of e power j omega in this form to apply partial fraction. So as we done here in equation 1. So you have to bring it into this form to apply partial fraction expansion, and you have to remember that the order of the numerator should be less than or equal to the denominator. So that is the main thing. I think it should be less than. Okay. So the order of numerator should be less than the order of denominator. So that thing you have to keep in mind. And looking at the signal, we have order 2 and here is 1. So that means we can apply partial fraction expansion. Okay. So if not, we have to take one more step by finding bringing by taking long division method, and you have to bring to a form such that the order of numerator should be less than that of the denominator. Then only you can apply partial fraction expansion. So that you have to remember while dealing with this one. So this one using partial fraction find x of n. So this one you try on your own and try to get the result for this. Okay, and I think I'll write the answer as well so that you can verify and the end. So the answer is 1 by minus 2 by 3n u of n. Okay, so now I will move to the next kind of the problem here. So the problem is given like this. It's given a signal x of n has DTFT x of e power j omega is equal to 1 divided by 1 minus a e power minus j omega. Now for this one we have to determine, so first one is x1 of n is equal to e to the power of pi by 2n into x of n plus 2, and second one x2 of n is equal to x of n convolved with x of n minus 1, and third one x of minus 2n. So this one is a little bit different. We have to apply property sometimes. We can solve without using the property as well. So that means we have to determine x1 of n, x2 of n, x3 of n for these values for given x of e power j omega. So that means we have to determine the DTFT of the following. That means this one is the DTFT for a signal x of n. Now x1 of n, x2 of n, x3 of n is given. So while dealing this, if you are applying some property, you have to use this x of e power j omega to get the DTFT of these signals. That is the meaning of this. Now if you go to the solution part, so let's take the first one. X1 of n is equal to, x1 of e power j omega, x1 of e power j omega is equal to summation n is equal to minus infinity to plus infinity x1 of n e power minus j omega n. Now if you substitute this value, n is varying from minus infinity to plus infinity, e power pi by 2 n into x of n plus 2 e power minus j omega n here. Now this thing I will replace with some other variable. Put m is equal to n plus 2. So that implies n is equal to m minus 2. We have to substitute n here, n value, and the limit here n will become m here, m varying from minus infinity to plus infinity, e to the power of, first I will write this term, x of m e to the power of pi by 2, n is m minus 2, and e to the power of minus j omega into m minus 2 here. Okay, now let's simplify this. M is equal to minus infinity to plus infinity x of m e to the power of pi by 2m and e to the power of minus pi here. So 2 to get cancelled here. Here this one e to the power of minus j omega m and e to the power of plus j 2 omega. Now with respect to this, these two I have to take, I will move this outside here. E to the power of minus pi into e to the power of j 2 omega summation m is equal to minus infinity to plus infinity x of n e power pi by 2m and e to the power of minus j omega m. So these two we can combine, and here we have e power minus pi, which value will be equal to minus 1. So that gives us minus e power j 2 omega into summation m varying from minus infinity to plus infinity x of m e to the power of minus j. If I take minus j, then it will be omega hope I have not made any mistake here, to the power of j n plus 2. Yes, okay, j2 omega. Yes, okay. So omega plus j pi by 2 into m here, as jj will get cancelled, so we'll get okay, j square minus 1 minus 1 plus. Now if you go further, this one, if you look this, we can apply the frequency shift property. Based on that, I can write like e power minus j2 omega x of e to the power of j omega plus j pi by 2 here. So that means if you want x1 of e power j omega, then in x of e power j omega, I have to replace omega with this term. So given x of e power j omega is equal to 1 divided by 1 minus a into e to the power of minus j omega. So now based on this, x1 of e power j omega is equal to e to the power of minus j 2 omega. So in this term, I have to replace e power j omega with this term. That gives us 1 divided by 1 minus a e to the power of minus j omega plus j pi by 2. So this is the DTFT for the signal x1 of e power j omega. Now if you take the second one, that is x2 of n is equal to x of n convolved with x of n minus 1. Now we know that convolution in time domain is just a multiplication in frequency domain. So if x of n is performed DTFT, we will get x of e power j omega. If x of n minus 1 is performed DTFT, then we will get e to the power of minus j omega into x of e power j omega. Because in place of n naught we have 1, so that's why this is time shifting property. Now using convolution property, so we can write like x of n convolved with x of n minus 1 will get x of e power j omega into e to the power of minus j omega x of e power j omega. Now you have to just substitute this value. X2 of e power j omega is equal to, because this is x2 of n here, so this will be x2 of e power j omega. So x2 of e power j omega is equal to x of e power j omega into e power minus j omega x of e power j omega. So that's why if you substitute the value, if you say we have x and x common here, so it gives us x square e power j omega into e to the power of minus j omega. So that gives us 1 divided by 1 minus a e to the power of minus j 2 omega, or we can write a square or j omega whole square. Yes, this term is b whole square into e power minus j omega. So you can split this and you can further simplify. So this will be our x2 of e power j omega. Now third one, given x3 of n is equal to x of minus 2n. So x3 of e power j omega is equal to summation n is equal to minus infinity to plus infinity x3 of n e power minus j omega n. So the limit n is equal to minus infinity plus infinity, x3 of n is x of minus 2n e to the power of minus j omega n. So I will replace this minus 2n. It looks like a scaling property. So put m is equal to minus 2n. So that implies n is equal to m plus 2. So the limit is m is equal to minus infinity to plus infinity x of m e to the power of minus j omega m plus 2. Okay, I think is it m plus 2? Okay, m by 2, m divided by 2. Fine, m divided by 2. So for the convenience, I am going to write this m is equal to minus infinity to plus infinity x of m e to the power of minus j omega by 2 into m. Now if you observe this, our x3 of e to the power of j omega is equal to x of e power j. So this is the scaling property. Based on that, we are writing this. So this is the scaling property, if you can remember this. So that gives us 1 divided by 1 minus a e to the power of minus j omega by 2. So this is our x3 of e power j omega. Now for the same one, you try this like x4 of n is equal to x of 2n plus 1. So for the same problem, x of 2n plus 1, so you have to find the DTFT. So try this one for the same problem and try to get the result for this. So I think I have tried to cover different types of problem in the for videos for that we have previously discussed. So basic problems using properties, finding inverse of that, and if the signal is given, how to, that means if phase and magnitude is given, how to find out the value of x of n, and so almost all kind of property problems or different types of most of them I have tried to cover in the videos regarding the DTFT. If you have any queries, do reply or comment in this video. I hope you have understood the method that I have discussed in this video. It's a little bit lengthier one, so thank you for your time.